In this video tutorial, we will introduce users to the new Tendon Smart Tools available in Adapt Builder version 21. The new Tendon Smart Tools were implemented to add efficiency to the tendon creation and modification process for the user. On screen, we have our multi-level tutorial model, but we're just looking at the tendons in one level, and we've already mapped the banded tendons using the Map Banded Tendon tool. So now we want to go ahead and create our distributed tendon layout and then do some modifications to our banded and distributed tendon layout using the tendon tools. So the new tendon tools are located under the tendon ribbon, under the modify panel and this Smart Tools icon. If we click the Smart Tools icon, this will open the Smart Tendon Editor, and the Smart Tendon Editor has 4 tabs of inputs that we can modify or use. Before we map tendons, we must first set up the settings and the default properties of the tendons that will be created using the Smart Tendon Editor. Under the Settings tab, we have options for mapping and delete colorize. The first option we have is High Point Locations. This controls the location where the program will place high points along the tendon created by the mapping tool. The first option we have for that is Boundary of Banded Group. In this case, the program will create a high point at the boundary tendons of a banded group and then run the profile straight at the high point over that banded group. The next option we have is Centerline of Banded Group. So the program will keep the high point of the distributed tendons at the center line of the banded group of tendons. The next option we have is Support Line X or Support Line Y. And in these options, wherever the construction line crosses over either a support line in the X direction or a support line in the Y direction, depending on which one we have set, the program will add a high point along the tendon in that location. The next option we have is Perpendicular to Slab Edge or Trace Construction Line. Choosing Perpendicular to Slab Edge, the program will keep the tendon perpendicular to the first slab edge crossed by the construction line drawn by the user. The Trace Construction Line option, the program will just follow the construction line drawn by the user. Next we have Cutted Openings and Run-Through Openings. If we cutted openings, the program will cut the tendon on either side of an opening and not run the tendon through the opening. So you'll end up with 2 tendons, one on either side of the opening. Next we have Run-Through Opening, and that will allow the tendon to just run through the opening, and the user will have to modify that before going ahead and analyzing the structure. The last option we have is the Minimum Tendon Length option. And with this option set, we would set the minimum tendon length we want. And then when we're in our mapping tool and on the delete button, the program will flag tendons that are smaller than the distance we have set here with a pink color, and the user can either choose to modify those tendon lengths or delete the tendon altogether. So before we go and map, we need to set our settings, and so in this case, I want to create our distributed tendons following this Y direction here. So I want my high points to be located at the support line, where the support line is located. So I'll go ahead and choose Support Line X direction. So my high points will be at where the tendon crosses a support line in the X direction. Now I'll come to my Default Properties tab and set up the default properties for the tendons created using this tool. In the force section, we have effective force per strand, and we'll set that to 26.7 kips. And we also have number of strands per tendon. In this case, we're going to start with 2 strands per tendon. Next, we have our shape options. This controls the shapes, or the span shape for the tendon along different spans. We have options for first span, mid span, or middle spans, and last span. We also have options to control the inflection points along these spans. The next option we have is end span. So if a first or last span for the tendon has a distance less than the L length set to the right of the end span shape, the program will use the end span shape. If the end span of the tendon is longer than this L value, the program will use the first or last span shape. The last options we have here are our control point heights from top and bottom fiber. In this case, we'll use 1 to take full advantage of the drape because our minimum cover to tendon is 1 inch. So now with this set, we'll go to our mapping tool. And before we map tendons, we need to create what's called boundary tendons. Because using the mapping tools here, the program will take the first boundary tendon and last boundary tendon and then map the tendons in between those boundary tendons. In this case, we'll go ahead and click the Create button and we'll create our first boundary tendon. Our first boundary tendon will be along this line of column supports. I'll click a 2-point construction line at the location where I want a tendon to be drawn. The program will then draw the tendon, and we can see that the program has added spans to the tendon, and these spans have some shape. We could check the shape by coming to Edit and clicking on Span Shape. And we can see the first span is cantilever down, and it's highlighted with the yellow color. The next spans are all reverse parabola, and they're highlighted with a blue color. So now that we have our first boundary tendon and we like the span shapes that it's using, we'll go ahead and come back to mapping and we'll create our second boundary tendon. And we'll do that along this last column support or line of supports here. Again, we'll click the 2-point construction line and the tendon will be created once we click the second point. Now we want to map our tendons between here. So we can do that by using one of these map distributed tools. The first tool, Fixed Spacing, will map tendons at a fixed spacing specified by the user, starting from the first tendon crossed by the construction line. That means that the spacing between the last map tendon and the last boundary tendon could be less than the fixed spacing specified by the user. We also have the option for max spacing, and in this case, the program finds an equal distance spacing either equal to or less than the value of the max spacing input by the user and maps the distributed tendons with that spacing. Lastly, we have number of tendons, and using this, the program or the user inputs a number of tendons, and then the program will space those tendons equal distance between the first and last boundary tendon. So in our case, we're going to use max spacing. And I'm not sure what spacing I need to come up with minimum pre-compression, but we can do that easily through the program. So first I'll go ahead and start with a spacing that I want to use. So the max spacing for this slab is 8 inches. This is an 8-inch slab. It's actually a 9-inch slab. So the max spacing is 5 feet or 8 times the slab thickness. 5 feet governs, so we'll go ahead and use 5 feet for our max spacing. Note we also have a use mapping region. The reason why we have this is because while the first and last tendon delineate the extents that the tendons will be distributed across, the length of the tendon is delineated by the outer slab edge. And in some cases, we may not want the tendon to go to the full length to the outer span edge. In this case, we can define a mapping region. And when we do that, the program will limit the length to the mapping region instead of to the outer slab edge, assuming the outer slab edge is outside of the mapping region. So in this case, we're not going to use mapping region yet. I'll use that just to demonstrate it shortly. So at this point with our input set, we can draw a 2-point construction line over the first and last boundary tendon that we want to map between. And the program will create tendons. So once I click my second point, the program maps the tendons and we can see the high points are following along the X support line in this direction. Same thing in this location here, except for when the program has a span smaller than allowed by the software. So here, on this edge, the tendon's last span was deleted, and the program continued the tendon span all the way to the slab edge. On this side, because there is a more distance between the high point and the slab edge, the program left the high point here. So first we need to check what our pre-compression is using the number of strands that we set in the default properties and the max spacing that was come up with by the software. So I'll go ahead and click on my information button, and I'll do a 2-point construction line. This is going to be a theme in this video, along the tendons that I want information from. And once we do that, once we click our second point in this lower box, the program will show us some information about the tendons. We can see the spacing between tendons, which is 4.8 feet, the number of tendons we crossed with the construction line, which is 5, the total number of strands in the tendons we crossed, and the pre-compression value with the tendons that we crossed. We can see that the pre-compression value is less than our minimum pre-compression needed by ACI code. So in this case, we need to either change our number of strands or remap our tendons with a lower spacing. So I'll go ahead and remap our tendons with the lower spacing. Before doing so, I'll go ahead and delete one set of tendons where we split the tendons in the opening. I'll explain why in a few minutes, or in a few seconds. So I'll come back to my max spacing tool. And again, remember when I map this tendons using max spacing, the tendon used the first and last tendon as the boundary and then distributed tendons between those. So this time, with tendons already distributed between them, the program, when we draw our construction line, will delete the tendons between the first and last boundary tendon that were crossed by the construction line. Therefore, I deleted these tendons before because I know I'm going to draw my construction line here, and so I want if I didn't delete these tendons down here, these tendons would be kept and more tendons would be generated in this location. So I'll go ahead and choose max spacing, and I'll change my max spacing down to 4 feet. And then I'll draw a 2-point construction line over the tendons, catching the first and last boundary tendon. When I do that, we can see the spacing updates, and we can now come to our information and do another 2-point construction line and find out information about the tendons that were created now. And we can see now that spacing is at 3.8 feet. We crossed 4 tendons for a total of 8 strands, and for the area of slab that we covered, we did a 128 psi for pre-compression. This is higher than the 125 pre-compression needed minimum for ACI code. So we'll go ahead and accept this value, and now we can go ahead and start to edit our tendons because we have a preliminary tendon layout here. So we'll go ahead and click on the Edit tab, and we can edit different aspects of the tendon. For example, we can edit the CGS height. So the CGS height here is for the whatever point you're at. So if you're at a bottom point, this will be from the bottom fiber. If you're at a top point or a high point, this will be from top fiber. So if I change this to 2 and then I just line select close to the point, the control point height that I want to modify, the program will then modify that control point height. We can do the same along the high points here. We'll go ahead and change these back to 1 as we were just demonstrating this tool. Next, we have our number of strands, and when we click this, the program will color code the tendons per the number of strands. So we can easily see the different number of strands in the model, and we can go ahead and change strands along tendons if we want to as well. Again, this is using a 2-point construction line crossing the tendons we want to modify. We'll go ahead and change this back to 2 strands per tendon and move on to our force input. Our force input allows us to change the effective force for tendons. If there are calculated force tendons, those tendons will be shown as yellow, and the user will not be able to modify those tendons. But for the tendons shown up in green, we can go ahead and, or in any color besides yellow, we can go ahead and modify the effective force for those tendons. So we could say, for example, here, these 2 tendons are 32 kips. And so the program will color code the different forces in the model as well. Again, we'll change this back. Well, instead of changing back, I'll just use my undo tool and undo that change to the force. The next option we have is mode. So in this case, we can change the mode of tendons in the model. We can see that distributed tendons were created with spline tendons because that was the last tendon shape that was used when creating a tendon. So we'll go ahead and change those to straight line because they are, in fact, linear tendons. However, our banded tendons look a little kind of kinked with this linear tendon shape. So we're going to go ahead and change those to spline tendons so that we can give a better curvature to the tendons and a more smooth look. Now, one thing we can notice is after changing to spline, the tendon bumps out into the opening in this location, or very close to the opening in this location, and actually in the opening in this location. In addition, we can see that the tendon kind of hump out behind the column in these locations here. We can modify that or control that by adding swerve points to these tendons. So I can go ahead and come to my mapping tool and click add point. And in this case, I want to add a swerve point along my spline tendons. So in the middle here, I'll go ahead and add a spline point just after the control point at the wall. And I'll do the same on the other side here. And we can see this kind of straightens the tendon, and the tendon no longer bumps into the opening. However, our tendons are still bumping out in this span, so I'll add another swerve point back here to help keep the tendon straight in this location as well. We can see we already have a swerve point in this location. So again, we can add more swerve points. And in this case, I want to add these swerve points kind of near this reentrant corner. And then again, I'll go ahead and add some swerve points to control the bump of the last span based on the spline curvature shape. So now we can see our tendon still comes close to the edge here, so we need to move these swerve points down some. So we can click on move, and we'll choose swerve point again, and then we'll just line select near the swerve points we want to select. Once we have them selected, the swerve points that were selected are highlighted in red, and the new location of the swerve point is shown near the mouse pointer. So wherever we click our mouse, our swerve point will now be entered. And we can do that for both ends. And now we have a little bit smoother curvature. We have a little bit of a bump out here, but again, we could just go ahead and add swerve points to control that inside this span. And we could go ahead and move the swerve points or high points even further to get a better shape here if we wanted. So in addition to adding points, we can delete points. In this case, remember we had the short span created in the tendons here, and we don't want that. We want the span to just go from high point here, reverse parabola, all the way to the slab edge here. So I'll go ahead and use my delete point tool and line select close to the points I want to delete. Once we do that, we were on swerve point. So I need to change the high point and then line select over the points we want to delete, or close to the points we want to delete. Once we do that, we can see that the span shape has been changed some because there's no longer a lower control point here. So I'll come back to my edit window and click on span shape, and we can see that it's now cantilevered down. So I can change this by just line selecting over the spans that I want to change to reverse parabola. So I'll set this to reverse parabola. You can see we have every shape available, so we can modify any shape. If we try and change a mid-span to a cantilever shape, the program will ignore that change because a cantilever shape is only available for end spans. So we'll draw our second point of the 2-point construction line over the tendons, and quickly the profile is changed. In addition, we can move points. So I come back to mapping and I can move points. And so we want to move these high points to align with the band. So I'll go ahead and line select over the points I want to move to select the points. But notice using the move point, the move will be the same distance for every point in that location. But we may not want to move the points at the same distance. We may want to kind of align the points along a line. So to do that, I'll exit out of the Move tool and I'll use the Align tool. The Line tool is the same. We just window select or line select over the points we want to move. It shows that we have a swerve point that it finds, and it says it's not going to add that to the selection set. So that's okay, because we don't actually want to move the swerve point in this location. We just want to move the high point. So now we'll go ahead and draw, with these points selected, we'll draw a 2-point line where we want the tendon high points to align to. So in this case, I'll draw it here, and the program will move the high points along that line. And we could refine this further using the Align tool if we wanted. For example, I could select these and then kind of refine them a little bit so it kind of curves up more instead of a straight linear line. The next options we have are Cut to Region or Trim Extend. For Cut to Region, the program will allow you to cut the tendons from a certain region. So for example, let's say the contractor has come and wanted to add an opening in this location here. Let's say let's go right here. And so we have this new opening, and our tendons are now passing through this opening. So to revise this, all we have to do is quickly come to the Tendon Smart Tools, go to our Mapping tab, and click on Cut to Region. We can now draw a region around this opening, and the program will cut the tendons that fall within the region to the edge of the boundary region. When I'm done drawing my region, I just right-click my mouse and choose Close and Accept. The program then cuts the tendons quickly through this opening. The next option we have is Trim Extend, and this is the same as before. We set a tolerance, and then we line select the tendon that we want to trim or extend to the slab edge, and the program will pull that tendon back to the slab edge. In addition to the Smart Tools, we also have made some improvements to the Map Banded tools. So I'll go ahead and turn on my Y direction support lines. Well, I'll turn on my X direction support lines, and we'll just select one so I can bring up the Map Banded Tendon dialog window. And in the Map Banded Tendon dialog window, we can see the new inputs to the window that we've added. The first set of inputs is we can either choose to balance based on self-weight or self-weight and dead load. And this dead load includes all dead load applied to the default dead load case of the software. The next new option is tendon trim tolerance. So if a support line falls outside of a slab region, within this tendon trim tolerance, the program will cut the tendon it created when mapping the tendons back to the slab edge. If it falls outside of this trim tolerance, the program will just create the tendon outside of the slab, and the user would have to modify that before analysis. The last input option here we have, or new input option here, is max span length for cantilever end shape. And this works like the end span shape of the Smart Tools, in that any span that is less than this distance will use the cantilever shape. Any span greater than this distance, or end span greater than this distance, will then use the first or last span shape depending on which it is along the support line, either the first or last span. Lastly, I want to point out that we have some improvements to the mapping tool related to the support lines. For example, we can see that we have two support lines in this location. Let me go ahead and delete these mapped tendons and show it better. So we have 2 support lines in this location. The program now is smart enough to know that if the support lines end and start at the same location, that the program should keep the tendon continuous through both support lines instead of split the tendons at each support line. So if I map distributed tendons here or banded tendons here, we can see that the program makes one continuous tendon along these 2 support lines. Another improvement is that when we create tendons in a beam, the program will keep the tendon off the center line of the beam ever so slightly. This makes it easier to view tendons if we have 2 tendons per group along the beam. For more information on the SMART tools or the improvements to the map banded tools, please refer to the help file, which can be accessed underneath the help menu. If we click on the help menu, we can open up the help file, and on the left-hand side we have different topics. Under the tendon ribbon, we can find the topic for Smart Tendon Editor. For more information, please visit us at www.riza.com or send us an email to adaptsupport@riza.com.